from past software testing question papers quiz 1 2024 October 27, and this question is very important related to du pairs and du paths. A annotated control flow graph given below. So this is a control flow graph given CFG question. There consists of 5 vertices or 5 nodes, 1 2 3 4 5, and this is the final vertex. 5 is the final vertex, that is it represented with double circles, right? And this is the arrow starting from the, this arrow represents the start node. So that is 1 is the start node, start index. Based on the above data, answer the sub questions. So how many du pairs are there for the variable x? So for the here there are 3 variables. So that is x, y and z. See, these are 3 variables x, y and z are defined at node 1, right? Here this is node 1, defined at node 1 a, b, c. Variables x and y are again redefined at node 4 and node 3, right? Redefinition of x and y. So and uses. So what are the uses? X is less than y, this is the use, and x is greater than or equal to y, this is the use, this is the use, this is the definition, that is redefinition RD. This is the redefinition of the x, this is the redefinition of y, this is the x, this is the definition of x, y and z both, and this is the use cases, and this is the use of x, use of y. Okay, this is the control flow graph. So how to solve this question? In the question they mentioned asking how many du pairs. Du pairs, they are asking to calculate the du pairs for the variable x. So what is meant by du pairs? Means du, u means use, d means definition, definition and use pairs for the variable x. There is a path or specific path. There is a path from definition to use case. So this is the definition to use, there is a path. So without redefinition, these are the pairs. Du pairs means we are calculating the pairs, that is definition use pairs, where it is defined, where it is used. Du pairs definition at generally at nodes, definition we defined at the nodes and we use at the edges, we use at the edges. So du pairs means definition and use pairs, that is where we are using at edges and defined at nodes. Du pairs of the variable x means there is a path for that variable x, that is definition to use path, that is here it is defined, right? We are going to using at this edge. So at this edge, so this is a path, 1 2 3 is a path. Without redefinition, again redefinition is not possible, this is important. Without redefinition, this is the du pairs. So x, so for the variable x, so write the definition. So definition of the variable x, where we define the variable x, variable x is defined at, that is x equals to a, right? X equals to a is defined at node 1, that is defined at node 1. This is the set of values, and x is defined at here node 4, that is z equals to x equals to z, right? That is node 4. So variable definition of the x is 1 comma 4, and use of x, where we use x variable at edges, right? These are nodes, that is node 1 and node 2. These are nodes, definitions are generally nodes, the uses are generally edges. So where we are using the x variable, x less than y, here, right? 2 2 3, that is we are using at the edge 2 2 3, and we are using at the edge 2 to 4 also. 2 to 4. We are using the edge 2 to 4, and we are using it node also. See, generally users are represent the edges and generally edges, but nodes are also it's possible. So we are using at the node 5, that is print x, right? We are using the variable x by printing, so that is at a node 5. That is first du pair is from we are definition and use, where we definition at node 1, right? So 1 to, so this one 1 to 2 to 3, 1 to 2 3, that is, please check here it is definition, here using, so there is no redefinition, right? No redefinition, so no redefinition. This is the first du pair. So du pair, first du pair 1, okay, without redefinition. So next one is 1 2 2 3 is completed, right? Next 1 2 2 4, so that is 1 2 2 4 is also a du pair. So definition of the variable x and use, this one use, there is no redefinition, right? 1 2 2 4 up to edge, here there is no redefinition. 1 2 2 4 redefinition, that is second du pair. So it is a second du pair. And third one is 1 to 5, so 1 to 5, 1 comma 5, so that is definition. Use is at 5, but the path is 1. How we go to 1 to 5, node 5? 1 2 4 or 5, so here there is a redefinition, right? Or we go 1 2 3 4 5. For the variable x, redefinition is there, redefinition of x, redefinition of x variable, redefinition at the node 4, that is x equals to z, that is x equals to z. So this is not a du pair, this is not a du pair. 1 to 5. Next one is fourth one, 4 comma 5 is a du pair. 4 to 5, so that is, this is the definition, that is x equals to z, and this is the use, that is print x. So this is a valid, no redefinition, so no redefinition, and this is a valid du pair. So 1 2 3 are valid du pairs. Next one is 4 to, fifth one is 4 to 5 is completed, 4 to 2 3, 4 to 2 4, so 4 comma 2 3, and sixth one is 4 comma 2 4. We are checking every pair, that is the combination, that is 1 4, so this is the definition, and 2 3 2 4 and 5, right? First we are checking for this 3, next for 4, for variable x, variable x. So 4 to 2 3, right? So 4 to, how do we go back? This is the path direction. 4 to 2 3 is not a valid du pair, there is no path, there is no path, right? So arrow directions are important, arrow direction. So this one 4 to 2 4 is not possible. Question is 3, but the given answer is 4. How the answer is 4, I don't know. Up to my calculations, answer is 3 only. Question, standard gate or ISRO paper question. Sometimes they consider this node is a conditional node. Sometimes they consider this node z, x equals to z is a conditional node. Conditional node, that is that they are using Here they are using only z, the variable z, so not x, so they don't consider the redefinition also. But according to lectures, answer is 3. How the answer is 4? We calculate for this variable y also. Just try, we will try. So for the variable y, so that is the definition and use, right? Use also. So where we define the y, variable y is defined, y equals to b is defined at node 1 and 3. Node 1 and 3 are the definitions, that is node 1 comma 3 are the definitions and use cases where we are using y 2 to 3h, 2 to 4 and y and 5, 2 to 3, 2 to 4 and 5. So 2 to 3h, 2 to 4h, and at node 5, that is print y, we are using the variables du-Pairs define, definition and use pairs use. So 1 2 2 3, 1 comma 2 comma 3, this is the first pair. So redefinition is possible. So is a valid du-Pair? We will check yes or no. 1 2 2 3, right? 1 2 2 3. So that is node 1 is definition of the variable y and 1 2 2 3 is a path used at 3. So is a no redefinition. So valid du-Pair, yes. 1 2 2 4, 1 2 2 4, here the definition and use no redefinition and it is a valid du-Pair, yes. To 1 to 5, so third pair is 1 to 5. So here the definition D and use, so no redefinition. 1 to 5. So 1 to 5, how we are going? Here also we will go, right? 1 to 5, 1 2 4 comma 5. So definition of y at node 1 and use of y at node 5. Use is here node 5. So 1 2 4 5. Yes, this is a valid path. Yes. 3 2 2 3. So 3 is definition and 2 3 is the node, right? So first to use second definition. So it's not a valid path. Correct valid path is not a correct valid path for the variable y, not x, variable y. So 2 to 3 is not possible. So that is definition 3 2 2 3 is not a valid du-Pair. In the same way 3 comma 2 4 is a valid du-Pair. 3 comma 3 is the definition of y and 2 4 is the use. This is also first definition, after use is not possible. And last one is 3 comma 5. Last pair is 3 comma 5, that is definition at y of definition of y is at 3 and use is at node 5, that is print y. So this path is possible, it is a valid du-Pair. So another du-Pair is there, that is 3 comma 5, valid du-Pair, no redefinition, yes. For the variable 4, the number of du-Pairs are 4. Du-Pairs are 4 for the variable y. So how many du paths are there for the variable x? So that is from the previous question, definition of x equals to node 1 node 1 and node 4, and definition of y equals to node 1 and 3. So use of x equals to 2 to 3, 2 to 4 and node 5, and use of y equals to 2 to 3, 2 to 4 and 5. Du pairs for x are 3 according to my question, but the answer is 4, are 1, 2, 3, 1, 2, 3 and 1, 2, 4 and 1, 4, 5. 4, 5. These are the du pairs for x. So these are x equal to 3 means number of du pairs. Okay. For variable y, du pairs are 1, 2, 3, 1, 2, 4, another du pair. So this one 1, 2, 3, 1, 2, 4 and 3, 5 and 1, 5 also possible, 1 to 5 also. So how many unique du paths? They are asking unique du path. So what is du path means? Definition, use, path. It should be def clear path. Definition, use simple path, that is simple path. Definition, use du means definition, use paths, that is simple paths. The path should be def clear. Clear means definition clear path. First definition and use second. First definition and use second. So in this question they are asking for variable x, right? So for the variable x, so these are the du paths. So first one is 1, 2, 3. That is how we going path by using 1, 2, 3. This is a simple path. Simple path 1, 2, 3. So this is the definition, this is the use. Definition first and use second. Okay, this is the first du path 1. First du path 1 and second one is 1, 2, 4. So that is definition of the variable x. Second use. So 1, 2, 4 is a simple path. So this is also a du path, valid du path. And third one is 1, 5, right? No, 4, 5. 4, 5. So first definition and use. So this is a path from 4 to 5. There is an arrow. Path for the variable x 4, 5 is a valid du path. So the answer for the variable x is 3. This one is correct. Variable y. So 1, 2, 2, 3, right? So variable y is defined here, y equal to b. So 1, 2, 2, 3. Use at this edge. So definition first and use is second. So 1, 2, 3 is a path. First one. 1, 2, 3 is a first path. For the second one, 1, 2, 2, 4. So 1, 2. Use is second, right? Definition is here. Y variable 1, 2, 4 is a second du path. 1, 2, 4 is a second du path. And for third one 3, 5. So definition is here. So definition is here of the variable y, defined y equals to z. So and use is at 4 to 5, print y 4 3 4 5 is a valid path. So 3 comma 4 comma 5 is a valid du path, and next 1 to 5. So definition of y and use is second, and definition is first. There is a path from without redefinition of the y. So there is a path 1 2 4 5 is a valid du path. For the variable y, it is 1 2 4 5 is a valid du path. If we go here 1 2 in this path 1 2 3 4 5 is not a valid du path, because this is a definition of the y and this is redefinition. It should not be def clear, so it's not definition clear, it is redefinition of the y again, so it is not a valid du path. So for this du paths are 4 for the variable y and du paths are 3 for the variable x. So these are the answers for these questions. Friends, if you like my videos, please share and like and subscribe my channel. Thank you for watching.